Have you ever experienced a moment so strange, so inexplicable that it made you question reality? A sudden wave of déjà vu, an uncanny coincidence, or a news story that felt eerily familiar? What if these weren't just quirks of perception, but glitches in the system, cracks in the facade of our everyday existence? This is the simulation hypothesis, a theory gaining traction among physicists, philosophers, and tech giants like Elon Musk. It proposes that our universe is a highly advanced computer simulation, designed by beings whose intelligence dwarfs our own. Imagine a program so complex that its inhabitants, us, remain blissfully unaware of the code running beneath the surface. This is the unsettling, mind-bending possibility we're about to explore. The simulation hypothesis isn't just a product of late-night internet forums or dystopian fiction. It's a serious philosophical concept. First proposed by Oxford professor Nick Bostrom in his 2003 paper, Are You Living in a Computer Simulation? Bostrom argues that if civilizations reach a point where they can create such simulations, the number of simulated realities would vastly outnumber the one base reality we presume to inhabit. Even Elon Musk believes there's a 1 in billions chance we're living in base reality. Could there be clues hidden in plain sight, whispering of a deeper, more synthetic truth? In the next section, we'll delve into the intriguing signs that suggest our world might be more matrix than we realize. From strange quantum phenomena to uncanny glitches in our everyday lives, we'll explore the cracks in the fabric of our perceived reality. The simulation hypothesis challenges our fundamental understanding of reality. It suggests that everything we perceive could be part of a meticulously crafted digital tapestry. Imagine a computer program so advanced that it simulates not just the physical world, but also our inner lives, our relationships, and our entire history. Nick Bostrom brought the simulation hypothesis to the forefront with his groundbreaking 2003 paper. If the technology to create such simulations exists, then the number of potential simulated universes would dwarf the number of real ones. The simulation hypothesis hinges on the existence of a civilization vastly more advanced than our own. Some speculate that they could be our descendants, humans who have long surpassed our current technological limitations. Others propose that the creators could be an entirely different species, beings with intellect so alien that their motives and methods remain incomprehensible to us. The possibility that civilizations far older and more sophisticated than ours exist out there, capable of manipulating the very fabric of reality, is both humbling and awe-inspiring. But the question remains, if we truly exist within a simulation, would we ever be able to know for sure? The implications of the simulation hypothesis extend far beyond theoretical physics and computer science. It delves into the very core of our existence, challenging our understanding of free will, consciousness, and the meaning of life itself. If our reality is a sophisticated computer program, then what does that say about our choices, our relationships, our hopes, and our dreams? If our actions are governed by lines of code, then the concept of free will might be nothing more than an illusion. The simulation hypothesis forces us to confront the limits of our knowledge and the very nature of our existence. We've all experienced that eerie sensation, the unsettling familiarity of a moment that feels lifted from the script of our lives. Déjà vu, French for already seen, is a phenomenon that has puzzled philosophers and scientists for centuries. Some proponents of the simulation hypothesis suggest a more intriguing possibility. Could déjà vu be a sign of our simulated nature? A brief glimpse behind the curtain of our digital reality? Just like any software, this simulation could have its glitches, moments where the code stutters or repeats. For those who entertain the simulation hypothesis, déjà vu takes on a whole new layer of significance. The Mandela Effect refers to a collective false memory phenomenon where a large number of people misremember the same detail about a past event or cultural artifact. Named after the widespread belief that Nelson Mandela died in prison in the 1980s, the Mandela Effect encompasses a range of shared, misremembered details. Some simulation theorists propose a more radical interpretation. Could these collective false memories be evidence of our simulated reality being tampered with? Imagine that the programmers running our simulation decide to make a minor adjustment to the code, perhaps tweaking a historical event. While the Mandela Effect remains a topic of debate, its existence raises intriguing questions about the nature of memory and reality. Delving into the realm of quantum mechanics, we encounter phenomena so bizarre that they seem to challenge the very foundation of our understanding of the universe. One such phenomenon, the observer effect, suggests that the act of observation itself can influence the behavior of quantum particles. The famous double-slit experiment demonstrates this effect beautifully. When photons are observed, they collapse into particle-like behavior, passing through one slit or the other. For simulation theorists, this resonates deeply with the idea of a reality that is rendered or generated as needed. In the digital world, resolution is everything. But what if our reality too had a fundamental limit to its resolution? What if, at the very smallest scales, the universe was pixelated, composed of discrete units of information? In physics, the Planck length represents the smallest possible unit of distance, a scale at which our current understanding of physics breaks down. Some physicists speculate that space-time itself might be quantized, meaning that it exists in discrete units, much like the pixels on a screen. This idea provides a fascinating link between the digital world and the realm of quantum physics. For decades, science fiction has tantalized us with visions of immersive virtual realities, worlds indistinguishable from our own. But what was once confined to the realm of imagination is rapidly becoming a tangible reality, thanks to advancements in computing power, artificial intelligence, and virtual reality technology. Today, we stand on the cusp of a technological revolution where the creation of increasingly sophisticated simulations is no longer a question of if, but when. As the fidelity of these simulated experiences continues to increase, it becomes increasingly difficult to ignore the implications for the simulation hypothesis. If we are already on the path to creating such convincing simulations, how long until we reach a point where those simulations become indistinguishable from reality itself? Perhaps no technological advancement holds more significance for the simulation hypothesis than the development of artificial intelligence. As AI systems become increasingly sophisticated, capable of learning, adapting, and even exhibiting creativity, we are forced to confront profound questions about the nature of consciousness itself. If a machine can mimic the behavior of a conscious being, can it be said to be conscious itself? If we are indeed living in a simulation, it's plausible that our own consciousness could be the result of advanced AI algorithms running on some unimaginably powerful computer system. The implications of this are staggering, challenging our understanding of free will, identity, and the very nature of reality itself. The sheer scale and complexity of our universe are often cited as arguments against the simulation hypothesis. Simulating even a small portion of the observable universe would require computational resources far beyond anything we can currently imagine. However, proponents of the simulation hypothesis often point to the potential of quantum computing as a possible solution. Quantum computers harness the properties of quantum mechanics to perform calculations exponentially faster than classical computers. For those who entertain this simulation hypothesis, quantum computing offers a tantalizing glimpse into a future where simulating entire universes might not be as far-fetched as it seems. Section 4. The Creator Paradox. If we become the architects, What does it mean for us? The rapid pace of technological advancement, particularly in the fields of simulation, AI and quantum computing, presents us with a profound and unsettling paradox. As we inch closer to the ability to create simulated realities indistinguishable from our own, we are forced to confront the possibility that we ourselves might be living in such a simulation, created by beings far more advanced than ourselves. This recursive loop of creator and creation, simulator and simulated, raises profound philosophical questions about the nature of reality, consciousness, and the very meaning of existence. If we are indeed living in a simulation, does it diminish the significance of our lives, our relationships, our accomplishments? Or does it perhaps suggest a deeper, more interconnected reality, where the lines between the real and the virtual, the creator and the created, blur into a tapestry of infinite possibility? In the heart of quantum mechanics, a realm of probability and uncertainty, lies an experiment so baffling it has haunted minds for over a century. This is the double-slit experiment, challenging our understanding of reality. Imagine a barrier with two narrow slits and a screen that detects particles. Fire individual photons at the barrier. Logic says they pass through one slit or the other, leaving two distinct bands. But instead an interference pattern appears, characteristic of waves. How can this be? How can individual photons create a wave pattern? This is the quantum conundrum of the double-slit experiment. The wave-particle duality in the double-slit experiment is mind-boggling. Things get stranger with observation. A detector can determine if a photon passes through a slit. Observing destroys the interference pattern. Without observation, photons behave like waves, creating an interference pattern. Observing makes them behave like particles, leaving two distinct bands. This is the observer effect, a perplexing aspect of quantum mechanics. The observer effect, as shown in the double-slit experiment, has profound implications for our understanding of reality. If our universe is a computer simulation, the observer effect gains new meaning. Imagine our universe is only detailed when observed, like a video game rendering only the player's surroundings in high detail. This saves computational resources, allowing for a more complex world. Could our reality work the same way? Does observation trigger our universe to render in detail? The double-slit experiment and the nature of reality. The double-slit experiment, with its wave-particle duality and observer effect, challenges our classical intuition. It suggests the universe operates on principles far stranger than we imagined. Our perception of reality is just that, a perception. The universe might be far more fluid and interconnected. Observation might shape the reality we observe. The double-slit experiment reminds us of the mysteries at the heart of our existence. Are we puppets on a digital string? The simulation hypothesis questions the nature of free will. If our universe is a simulation, what becomes of free will? Are we authors of our actions or puppets of a pre-programmed symphony? The implications are unsettling. Imagine every decision preordained, woven into the simulation. Is our sense of agency just an illusion? If choices aren't our own, what of responsibility? Can we be held accountable for predetermined actions? Our ethical frameworks might crumble. The question of free will in a simulated universe is a philosophical abyss. Section 2. The shifting sands of morality. Values in a virtual universe. Morality, a cornerstone of human civilization, is often framed as universal principles. But what if these principles are fluid constructs, shaped by our simulated reality? If our universe is a simulation, right and wrong might be subject to the simulator's whims. Moral codes could be adjustable parameters within the grand simulation. Imagine a simulation exploring ethical behavior evolution. The simulator could tweak parameters, altering consequences, observing moral adaptation. This raises questions about the nature of our moral intuitions. Consciousness and code, the essence of being in a simulated world. The simulation hypothesis challenges our understanding of consciousness. If our universe is a simulation, what does that imply about our consciousness? Are we just complex algorithms generating the illusion of self-awareness? Could consciousness be an emergent property of complex systems, biological or digital? The idea that consciousness could be simulated is both exhilarating and terrifying. Section 4. The search for meaning, purpose and significance in a simulated existence. The realization that our universe might be a simulation can evoke a sense of existential vertigo. If everything we perceive is an illusion, what becomes of meaning and purpose? Does our pursuit of knowledge hold any real weight in a universe devoid of inherent meaning? Perhaps the simulation hypothesis offers a radical new perspective. If our reality is a simulation, its creators must have had a reason for creating it. The search for meaning becomes a quest to understand the motives of the simulators. Section 1. The Unanswered Question. We've journeyed from the familiar sensations of déjà vu to the mind-bending realm of quantum mechanics, exploring the compelling arguments and unsettling implications of the simulation hypothesis. We've peered into the heart of the double-slit experiment, where particles behave like waves and observation itself seems to shape reality. We've pondered the philosophical quandaries of free will, morality and consciousness in a universe potentially governed by lines of code. Yet, the central question remains unanswered. Are we living in a simulation? There is no definitive proof, no smoking gun that irrefutably confirms or denies our simulated existence. We are left suspended in a state of wonder and uncertainty, our intuition grappling with the profound implications of a reality that might be far stranger than we ever imagined. The simulation hypothesis at its core is not about finding definitive answers, but about asking the right questions. It forces us to confront the limits of our perception, the boundaries of our knowledge, and the very nature of reality itself. The simulated horizon. The simulation hypothesis shifts our perspective, encouraging us to question our assumptions. It invites us to embrace the possibility that our universe is far more wondrous and mysterious. Whether simulated or real, the implications for our lives are profound. If simulated, exploration becomes limitless. If real, cherishing our reality becomes urgent. Thanks for watching Bilmo Chronicles. Don't forget to like, comment, and subscribe for more deep dives into the unknown.